In this video, I will talk about the concept of working stress. Okay, so by the time you have already learned the concept of stress as well as strain, and you have also learned the Hooke's law. Okay, now it's time to learn about the concept of working stress. Okay, so why this is? Because as an engineer, always we have to deal with this working condition of the stress. Okay, so before jumping into this working stress, first we need to recap something. Okay, so the first thing is that we have learned stress, you have learned strain. Okay, and you have also learned that if the strain is within certain limit, in that case this stress sigma varies linearly with this strain, that is epsilon. Okay, and this is known as what? Yes, this is known as Hooke's law. Okay, and what is the implication of this Hooke's law? Simple, that if you have a structure like this, just consider a simple beam. Okay, so this is the beam, and now you are applying a load like this. Okay, as a result of this application, what will happen? Simply the beam will deflect. Okay, so after deflection, this is the beam. Okay, now if the load, okay, if the magnitude of this load P is such that your strain is within the limit. Okay, so due to the magnitude of P, let's say the P is very much small, the strain is within the limit, and here Hooke's law is valid. So as a result, when you simply remove the load, again the structure will come back to its initial position. Okay, and there will be no more deflection. So this is the implication. Now what happened if the load is more than this limit? As the load cross this limit, simply the Hooke's law is no more valid. And what will happen then? Let's say now your load is too much high, and it is, let's say we are denoting the load with let's say n times of P. Okay, and now the deflected shape is like this. Okay, and once you remove the load, what will happen? Yes, the structure will come back to its initial position, but partially. Okay, so here you can see that there is some permanent deformation. So as an engineer, do you want this permanent deformation in your structure? Of course not. So what you have to do, you have to always maintain the structure within this Hooke's law limit. Okay, or you have to maintain the stress in such a manner that this strain remains within the limit. Okay, so what you have to find for that? You have to find the stress corresponding to the limit of proportionality. Okay, the limit of proportionality. Why the limit of proportionality? Because here the stress is proportional to strain, or we can say that simply Hooke's law is valid. Okay, very simple thing. Now how to find out the limit of proportionality? Okay, so that's the $1,000,000 question right now. If you have a material, just consider we have a structural steel. Okay, structural steel, and now we have to design a structure based on this steel property. So for that we need to find out the stress corresponding to limit of proportionality. How to find that? So for that we have to use a diagram that is known as the, what is that? Yes, you are right. That is the stress strain diagram. Okay, stress strain diagram. Okay, so for that we have to perform a tensile test on any steel specimen, and if we simply plot the strain in this axis, okay, here is strain epsilon, okay, and in the ordinate we will plot the stress. Okay, so here is your stress or sigma. Okay, so it looks like something this. Okay, so first initially it is straight line. Why straight line? Because simply here stress is proportional to strain, and that is valid up to this point, and this point is known as the limit of proportionality. Okay, let's say this is a point. Now again you are increasing your load. What will happen? Yes, now this has crossed the limit of proportionality. That means the Hooke's law is no more valid. So it is not straight line anymore, and it becomes curved. Okay, it becomes curved, and now we have reached a point. Let's say this is B. In this point what will happen? If you again increase the load, what will happen? The stress is not increasing much, but your deformation is too much compared to the increment in stress, and this point is known as yield point. Okay, and again let's say you are increasing your load. What will happen? The material somehow recovers, and again it's, well, let me clear out it. So we have reached up to yield point. Now again you are increasing the load. Okay, what will happen? The material will recover and it will reach up to the maximum stress level, and then it will crash. Okay, so we are defining this maximum level as C and the crashing as D. Okay, so now come to one by one. So first initially we have a point A that is known as limit of proportionality. I am using the abbreviated form. Second, you have point B that is known as yield point. Okay, sorry. So this is yield point. Okay, and what is yield point? Here, without any appreciable increment in the stress, the strain increased too much. Okay, and third point is, what is that? Third point is the ultimate stress or ultimate strength. Okay, and this portion is also known as strain hardening. Okay, strain hardening portion. Okay, and then finally we have reached point D, that is your crushing strength. Okay, or collapse strength or rupture strength. Okay, now we have started this video with the word working stress, but till now almost 8 minutes have over, but still you are thinking that why till now we have not encountered this term working stress. Well, to find the working stress, what we have to do, either we have to measure everything to find this limit of proportionality, and for that you have to use some sophisticated extensiometer. And not only that, the limit of proportionality you have find based on that extensiometer also depend on the accuracy of that instrument, and that is also a very tedious job. So what is the best way to find this limit of proportionality? Simply, in this diagram you can clearly find out this yield point. This is clearly visible. Okay, sorry, this is the yield point. It is easily available, or you can let me extend this, or you can find this one, the ultimate strength. Both are clearly visible in this curve. So once you have find out this ultimate strength or the yield point, what you have to do, let's say you are using your yield point. Okay, so you have find out this one, and what is your duty? Your duty is to find out the limit of proportionality, or you have to maintain a stress level within this range, so that in your structure there is no permanent deformation. That's the main motto. So to maintain your stress level in this range, what you can do, you can simply divide this yield stress, okay, that is sigma yp, by some factor of safety. I am using green color for factor of safety. Let's say this is n. Okay, so if let's say you are using n is equal to 2, so definitely your working stress sigma w, working stress is belonging somehow here in this range, and you are maintaining your Hooke's law valid. That's why there is no permanent deformation in your structure. Okay, clear? So that was the concept of working stress.